one page and your one chapter will be sorted and your 5 marks are secured. Let's start the chapter exploring mixtures and their separation. So mixtures can be basically of two categories, which is homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures are the ones where you cannot see the separation between the solute and the solvent, while the heterogeneous is where you can find the separation between the solute and the solvent. Homogeneous is also called as solution. Here are the examples of both. Solutions. Homogeneous mixtures, we'll have solute and solvent. Solute is a substance that will get dissolved and solvent is a substance that will dissolve the solute. The concentration terms. So the concentration can be measured in these three categories, which is mass by mass percentage, mass by volume percentage, and volume by volume percentage. When you say mass by mass percentage, it means that how many grams of solute is present in 100 grams of the total solution. So here it is solute and solution. When it is mass by volume percentage, it is the grams of solute in 100 milliliters of solution. When it is volume by volume percentage, how many milliliters of solute is there in 100 milliliters of solution. Here is the formula of these three, and these are the uses of the three concentration terms. Now, when you have a saline drip, it is of the concentration 0.9% mass by volume, which means you have 0.9 grams of salt in 100 ml of the solution. It is of sodium chloride. Moving to the solubility of substances. So the solubility can be of unsaturated solution, saturated solution, or supersaturated solution. Unsaturated is the one which a solution will contain less solute than which can be present in the solvent. Saturated solution is where you will have the maximum solute in the solvent. Supersaturated is you will have more solute than what can actually be in the solution at a particular temperature and pressure, because if the temperature and pressure will vary, these terms will also vary. Next, the methods of separation of these homogeneous mixtures. The first method is crystallization. In laboratories, the process of forming crystals from a saturated solution is called crystallization. What is crystal? It is a solid that is made up of the particles arranged in a regular geometric pattern. So these are the crystals which are formed. In this way, you can actually separate the homogeneous mixtures. Next process is the distillation. It is where a homogeneous mixture of two miscible liquids, different boiling point, which will have a difference of at least 25 degrees Celsius. So when you have a miscible liquids two and you heat which have two different boiling points, then one will start to evaporate, and when you collect the one, then you will have the two separate liquids, and this is how you do the distillation process. If the difference between the two liquids is less than 25 degrees Celsius, then we perform the fractional distillation. And the third one is the paper chromatography. It uses the differences in the interactions of the compounds with the solvent and the paper in order to separate them. So this paper chromatography can be used in order to separate the compounds by taking the advantage of the differences in the rate of the movement on the paper. So when you have homogeneous mixtures, the way you can separate them is either by crystallization, either by distillation, or by paper chromatography. Now moving to the heterogeneous mixtures. When we have the heterogeneous mixtures, then there can be various scenarios. So if we have the separation of the immiscible liquids, that is the two liquids which do not mix, then based on the density, we can separate them using the separating funnel, which is one of the methods. And the next method is the separation of the solid-solid mixtures. You can use the property of any of the solid in both. So one such method is the sublimation method. Suppose if we use the camphor and sand and you start heating this mixture, then the camphor will start to evaporate, and directly from the solid form it will again evaporate and go into the solid form. It will not go into the liquid phase in between. So that is called sublimation, and later it will undergo the deposition. In place of camphor, you can also use naphthalene and dry ice, which is solid carbon dioxide. So when you have a group of metals, you cannot combine them as they are in the solid form. First you need to melt the group of metals and then combine all the metals together, and then you can form the alloys. Once you form the alloys, you cannot separate them because they are made for a stronger, rigid, and they'll have more corrosion resistance. So that is the purpose why we make the alloys. Some of the alloys are following the brass, bronze and stainless steel, and these are the compositions of these alloys. And suspensions are one of the kind of heterogeneous mixture. So it is a heterogeneous mixture in which the solid particles are larger, 1000 nanometers, and are dispersed throughout a liquid or a gas without dissolving. So they are visible to the naked eye. But how do you separate them? You can do the sedimentation and then the filtration part. And even after this, if you find the suspensions, then you can go for the centrifugation and coagulation. So centrifugation, it is a laboratory and industrial process that uses the centrifugal force generated by rapid rotation in order to separate the components of a mixture, either liquid or liquid-solid. So suppose if something is moving in high speed in a circular motion, this will be the path of the motion. So there will be an inward force, which is centripetal force, and there will be an outward force, which is a centrifugal force. So this centrifugal force is the one which will move the larger particles out of this, and they will settle down. So that is the principle on which the centrifugal mission will work. So when it is rotating hard, whatever is the larger solute will actually come out due to the centrifugal force and will settle down, and the lighter particles will be on the top. And then you have the coagulation process. So in this you can add the powdered alum to this muddy water, and then the powdered alum will settle down along with the lumps of the mud in the water, and these settled impurities will be present down, and you can actually decant this part and you can get the proper water out of it. So in this way you can separate the mixture. So these are the ways by which you can separate the heterogeneous mixtures. Now moving to the colloidal part. So the one which is in between the true solution and suspension, it will neither act as a solution nor a suspension. That is what is called the colloid. What is the primary difference in all these things? In the solute of the solution, these are less than 1 nanometer in diameter, the solute in the solution. And when you have the solute in the colloid, it is in between 1 nanometer to 1000 nanometers in diameter. And in suspension, we'll have more than 1000 nanometers in diameter, which is visible to the naked eye. So examples of colloid are blood, milk, tomato sauce and ice cream, and they do not settle down over time as we can see in suspension process, but in colloidal process we do not see them to settle down over the time. Right, so next, the Tyndall effect. So the scattering of light by particles is known as the Tyndall effect. So if you actually flash a beam of light on a solution, it will actually pass the beam of light, but the beam or the strike is not visible in the solution. When you pass it through the colloid, you can actually see that the light is passing through it. But if you pass the beam of light through suspension, it will either block, allow or scatter the light. It will depend on the size of the particles which are in the suspension. But when a beam of light is passed through a solution, it allows the light to pass undetected. You cannot see the light passing through a true solution. But in a colloid, it scatters the light and the beam is visible. In the suspension, as I've already told you, it may block, allow or scatter the light. So, in colloid, we'll have two things, that is the dispersed phase and the dispersed medium. So, dispersed phase is basically the solute, while the dispersed medium is the solvent. Another important thing in your NCERT is about the emulsions, which you can read, and this is all which you have got in the chapter exploring mixtures and their separation. Hope you have got this and your 5 marks are sorted.